Hello everybody, my name is George. I am going to demonstrate a simple embedded server that I made on a microcontroller. This is an Arduino MEGA 2560R3. However, I only programmed it using pure C. So it's very portable. I can program a chip directly from what I've done, especially something in the ATmega family. Very portable. I'm going to be doing this with another device shortly. For proof of concept, I use this rapid prototyping. I used the Arduino libraries initially, and then I converted them all over to register level C programming. This device, so that's what that is. This is an Uno. It's not being used as an Uno. I'm simply using it as an interface so I can monitor some of the serial communications. So some of the, I believe the transmit line from one of these devices, I believe it's from my web page. So coming from this device is going out COM9. And this Arduino serial terminal is also going to be used to be monitoring some of the data. And I believe that's going to be from the microcontroller being sent out to the internet. We'll get to that later. So this looks complicated. Basically, this device, I'll tell you what it is in a moment. This is a simple web server. I've interfaced these two devices. How did I do that? And what is this? And what am I interfacing? USR-TCP232-T2. I'm going to check my spelling here. Excellent. This is the device that I used. This was a challenge presented to me. And I took to the challenge. And I'm spending a lot of time, and I'm having some fun with it. So it's a serial TTL to Ethernet module. Wow, look at everything it can do. It's a TCP server, client, UDP server, client, HTTPD client. Look at all these things into all kinds of applications, industrial, security, smart home, door checking, and a rice selling system. On the other side of the planet, they sell a lot of rice. We could use it, I think, maybe for wheat grain here. Building automation systems, etc. This is the simplest of their devices and the least expensive. So I purchased one of these. I've gotten very excited about it, and I purchased some of these for myself. This has WebSockets on it. So I'm going to explore those in another segment. So we're just going to work with this device here. So I'm going to minimize my browser. Get back to where I was. Okay. I have some COM ports here. Again, if I can find my camera. We'll sort out which ones these are in a moment, but coming from the internet, this is my web page. I believe this is going to be my web page, what it's sending. So it's going to come through here, and it's going to be displayed here. And I believe I've labeled these for you. Transmit from the server, receive from the web page. Okay, it's really being transmitted from the web page. And then it's going into the receive of the terminal, but you get the idea. I can only receive with a listener COM ports. All right, so let's discuss what I did here. I connected the microcontroller to the serial ports on this device. Why are they not connected directly to the device? Well, they are, but I had to use a logic level translator. So didn't do this intentionally, but you can see that the receive and transmit go into a logic level translator. Basically, so the 3.3 volts can talk to 5 volts. It's bidirectional, easy to implement. I had the voltages on this board. You put 5 volts into this board, it downregulates it to 3.3. It's a 3.3 volt device. So we can talk to each other. So that's kind of nice. I have to remember that. Arranging my wires for future videos. These two devices are talking to each other. Okay. Internet TCP packets coming in. Serial coming out. Microcontrollers processing them, maybe performing some action on them or nothing, sending stuff back out. What is it sending in and what is it sending out? I am not going to teach you about the internet and communications here, but you can look up basic HTTP and post and get, and you'll get a sense of it. There's a lot of good information out there. I didn't sort it all out for you, but I may have read most of it. Let's look at the code just to get you a sense of what's going on. haven't decided what to do here. Give you a demo and then look at the code. We got to start somewhere. I'm going to move this over here. I got a lot of tabs here. It's kind of nice in the Arduino IDE to use tabs. Cleans things up. Otherwise, you get one long, big, huge, monolithic piece of code. You could have also split those up into separate C files using a different development environment. Okay, include avrio.h. That's for my USART. So I put all my USART functions in here. Universal, serial, asynchronous, receive, transmit. I believe that's what it stands for. Okay. I read the MEGA 2560 datasheet. It's got a lot of code examples. It doesn't have everything for you. So basically, I have to initialize. 9600 was too slow, so I wanted to use 57600. Here's something interesting. When I looped my receive back to my transmit so I could see it on my terminal, I was getting a bit of garbage. Now, these settings should be identical. This doubles this and gives you 5600, and this gives you 56. No? Yeah. Whatever. This one does some doubling. So if you set it to 34, basically set it to half of 5600 and doubled it. This sets it directly to 57600. This didn't give me any garbage. This did. They should have been the same. So that's for some further exploration. I got that from a bad example that I saw somewhere when I started. But I'm defining my own code. I'm going to know what it does from now on. I set it for asynchronous 8-bit, no parity, one-stop bit. You could look up and see which bits I set in this register on the datasheet. Not provided, you'll have to look it up. Enabled receive and transmit. Wrote some code here for transmit and receive. Actually, didn't write it, sort of. And then I went to the MEGA site. They had some snippets of code, so I just borrowed those and kept their comments. Thank you, Microchip. I added this. I may need it one day. It's a nice way to flush the USART. You may have an interrupted transmission or something. A lot of print statements here because I needed to print strings and send them out the USART. A string always terminates with a null. Where's my first sloppy effort? Because I had to count the elements in each string to get the contact length for a web page, which you'll see later, I just threw this together. But because the string terminates with a null, these worked. I think these are duplicates now, just with different names. Also, I have some other string functions here. I think I gleaned that somewhere from an example somebody provided, and I did this with an actual count number. You use a lot of memory when you have a lot of strings. So, I'm storing a web page basically in print statements, so it's got to go into memory. You can store these in your flash. So this was my exploration of storing these into the flash. If I go into the first page, look at that. I stored this into the flash, and basically it reduced my memory by 73 bytes, which can be significant. These things can add up when you get a 100-line web page and only 2K of memory. So I'll put it in my flash. There's a special way to read it from your flash. That's it. So those are working, and those are for exploration later. All the USART routines. My first web page. Now, if you can look at this without all the print statements, look at that. Not that. That's a response from the server. From here down, this is an HTML page. It's got the doc type. It's got a header. I added a meta refresh. Remember that? So it updates every 2 seconds. Refreshes, goes back to the main page. I added a form. Created some submit buttons that use the get method. Sends a get request out to this IP, so I can talk to my microcontroller and send a get request to do something based on LED and the variable assigned to it. LED equals 1. So you see what that get request is generated from this and sent from the web page, pretend it's out here, through this to the microcontroller. Microcontroller gets that and sends something back, or it does something locally. In this case, both. So there's a form. Here's something interesting too. I'm generating 2 HTML lines, headers, header 3s. which basically display a 1 or a 0 depending on the state of the microcontroller hardware. Look at that. Reading a bit. If it's 1, I send a 1. If it's 0, I send a 0. I'm not really sending a 0. I'm embedding a 1 or a 0 into the web page. Interesting. Now I'm setting a flag 1 as false. So when I'm done, flags are set. There's another web page. So I have a bunch of flags. So let's go through the code. Max get. This is an array for receiving incoming get bytes. Well, I call them get bytes because I'm basically just looking for a string that starts with get. So I'm calling them get bytes. I'm storing them in an array up to 20 ASCII characters. So here's our code. Initializing these ports and pins. Output, LED input switch. Before I do anything, initializing the UART, not doing any flushing of the UART, and then I'm going to go into a while loop. So if I have something ready to receive, I'm going to respond to it. If there's something ready to receive in the USART receive buffer, I'm going to start reading it. If it's a G, that's important because that's maybe the start of a GET request. Maybe not. There are other Gs. Not too many. I can fix that later and just get one set just GE, parse for GE. This worked for now. So if it starts with a G, I'm going to read up to 20 characters, I believe that's what I said, into my buffer. And then when I get the count, if the count is 20, which was max get, remember I've got a string, 20 characters that I received from a web page coming into my microcontroller. I'm going to parse through those. And if I see a get 1, flag 1 is going to be true. I'm going to do something with that later. If I get a get 2, flag web 2 is going to be, so these two are web pages. Flag LED 1, flag LED 2, flag LED 3 are get requests from submit forms on the web page. So when I click a button on the web page, it's going to send a get / LED equals 1. Now, it didn't matter to me that this was 1, 2, or 3. I just parsed for the whole thing. They're uniquely distinguished by the 1. I didn't need to sub-parse this uniquely. I could have just separated the 1 from this and had a number of different variables in here sent along with it. That's some exploration for a further time. Great. So I set all these flags. What happens? If flag 1 is true, I go to web page 1. If flag web 2 is true, I go to web page 2. If flag 1 LED, look, I toggle the state of the hardware and toggle an LED. If flag LED 2 is true, I turn a bit on. Yes, on. Turn the LED on. Yeah. If it's 3, I turn the LED off. And what is a web page? It's just a bunch of print statements. Not sure if I went through this already with you, but it's just a bunch of print statements with the web page. This is take 3 of this video, so I may be repeating it myself. All right? If not, I'll go back to this. I'll have to review the video. Enough of this. I've kind of explained what the code is doing in here, talking to this and the talking back and forth. A live demonstration will actually help you see what it's doing. Now, first of all, this thing has to be on the network. So you need to know your network settings. Those are in control panel somewhere. You can find those, and you need to configure your device. Now, I have already configured the device, so it's talking a little fast there. I'm going to slow down. The IP of my device, it also has a web page for configuration on it, was set to this, which is on my network. No? I did this last time. There we go. I need to log in. Okay, I'm not going to save it. Let's open up that page. Let's move this. Current status of the device tells me the current IP of the device, MAC address, UART to Ethernet. That's the module name. Nothing's been transmitted. Local IP, I gave it a static IP. on my network. So it'll work. It's just one IP on a network ranging from 20 to 254, but you can't use 0, and I've used 1 for my gateway. Okay, this is an open source DNS server. It's there by default. So the only thing I had to change was this, the gateway, the subnet mask, and give it a unique IP. If you got a dozen of these in the lab, they have to each have a unique IP. You're going to have IP address conflicts. Let's go to the serial port section. I bumped up the baud rates to 57,600, 8 and 1. Okay, that's how we're communicating, and that's what I set up in the microcontroller as well, so they can talk to each other. I left the default local port number. So if you want to talk to the TCP, and I chose TCP server. I had all these choices, just TCP server. If I want to talk to this device's server, I have to use this IP address and this port number and this port number. Okay, I'm not going to do anything here. There have been occasions where I've needed to reboot my device. Let's just restart it. This isn't a reset, this is a reboot. This is messy. I really wish they'd fixed it, but I've contacted them. It doesn't really go back. Okay, all I did was reboot the device. I'm going to minimize this window. So where are we? Okay, I have a couple of clients here. So COM9, this is what's being received from the web page. So the web page, I'm going to put a URL in here. The web page is going to send stuff through here, voltage level translator to the microcontroller. I'm intercepting it right away. So I'm just intercepting the hardware communication here. It's not going through the microcontroller. Just intercepting it and sending it to a terminal. If the microcontroller is sending back something, I'm also intercepting it through here. These are hardwired to it, so it's connected to the receive and transmit from the Ethernet controller to the microcontroller. It's just hardwired through here, and I'm monitoring everything on here. So we can monitor the communications back and forth, microcontroller to internet. Pretend this is connected to the web page. If I get my scribbler on, I might be able to do something with that. Let's try. I'm going to do a screen scratch. Oh yeah, look at that. Nope, it's not working. It's working on the other monitor. Give me a second. Screen sketch. No, it's not working. Can't do it live. Another day, perhaps. Imagine I'm drawing a line from here to my web page. Okay. I will explore that further. I need to make better videos. I'm going to leave this here. So I happen to set up some IPs in here already, just in my notes, so let's find them. It's kind of cool. I can click on this. It should open here. Let's see. Oh, it's opening in the other page. Don't want to do that. I'll type it in manually. So I can still use this IP. Remember what I said the port that we're using? There's the port that we're using. Oh, I didn't want you to see this. I'm going to clear it. That actually happened when I clicked on the IP. It sent a GET request. Okay, let's see what happens when I just click on that, because I'm now talking to the server inside my device. So here's what happened. The web page did this. It's still looking for something. That's the old page. It didn't update. It's still looking. There's nothing there. I'm not getting a response. It's sending a GET request / nothing. It's not asking for anything. There's no default web page, no default response to just that IP. My microcontroller was not programmed to respond to that and send anything back. However, if I put in a /1, watch the magic unfold. Look at that. I'm just going to keep repeating. See? I'm sending a get1 now. I have programmed this to respond to a get 1, set this as true, and respond with a bunch of statements from web page 1, a bunch of print statements. So a bunch of print statements go out the serial port, go out as Ethernet TCP packets, right? Go to this go to the web page. So please understand, in this relationship, this is the client, this is the server. So the client was requesting something, and the server sent it back. Print statements, which once you're on this side, you send serial data on a packet. It makes no difference to the web page where it came from. That's just an HTML web page. Watch. I can view the page source and look at it. That is what I sent out from here. Isn't that something? Now, this is very useful because I had to count all of these, and I had to, initially, it was a lot of work. I could have written some code, maybe one day later. I'll put it all into a buffer, but for the time being, it was easy enough to count. 389. Now, if I save this, as an HTML only page, already saved it. I was preparing. Show it in the folder. Edit it with Notepad. It's on the other screen. Look at that. 389. So remember that. This could be a useful tool for you to, once you created some web pages and get the hang of it, I can use this to help me create a web page. It'll require some modification with print statements, some fiddling and adding some other stuff in there, like this is 0. Actually has to be, yeah, this remember in the code, if this or that, you print this or the other one. You're only capturing what it sent. So you're going to have to modify this, and I did that, and it wasn't so bad. Okay, I'm going to close that. That's the HTML web page. It's what we sent and what was interpreted, but that keeps changing depending on the status of things like the buttons. So I'm going to close that. So watch this LED, special effects. I put some foam on it. Look at that. It's turning on and off. And look at the request I'm sending. That was the LED request. That's what the submit form is submitting, a get 1. We discussed that earlier. It's updating every 2 seconds. Well, no, I'm overriding that by sending a get request. The page is automatically updating every 2 seconds. So whatever the last state of that was, it remains. State of pin. Should have put push button in there, but that'll mean counting more bytes. There's a push button hidden under there. Every time I press it, I move the foam and the LED. I won't do that this time. I'm going to watch. There's my finger. Now watch what happens when I press the button. Watch the web page. See the state of the pin goes to 1. Now I've released it. It's going back to 0. Now I slowed down the updates to every 2 seconds. Any faster, it might start going into the cache, and you're not going to get a real sense of the updates. And I wanted you to see the communications. So do you see them? Now, watch this. This is the web page that I'm printing with serial statements. See where the mouse is? I need a bigger mouse. Watch that statement. On the web page. See? It's sending a 1 to the browser, the client, and it's updating the web page with a 1. Dynamic web paging. 15 years ago, I had a project I called it Dynamic Data. So things have come full circle. It was an application. It's drawing a graph. I'm going to be drawing graphs on the website soon. Okay, so what else can I show you here? That was very cool. Oh, I created another web page, remember? It wasn't too hard to integrate more into this once I started. So here. Look at that. We can do the same thing. Notice the size has changed? I'll just do the same thing. Download, show in folder. It's popping up on the other screen. Edit with Notepad. 571 and 571. Look, the 571 match. They had to match. Content length had to match. I've been able to work around that yet. I have to send contact length. It's in an RFC somewhere. It says I should. It says I should. I believe it's in capital letters. Okay. And there's the web page. Now notice I have two forms. LED2, LED3 get request. So that's why I have two buttons. Now I know I'm getting some tweets already. What do those buttons do? LED on, LED off, LED on, LED off. There's only so many times I can do this. We're not trying to determine the mean time between failure for. I wonder if a submit button has an NTBF. I don't think so. The push button does. It may. Things wear down. These buttons don't wear down. Mechanical buttons do. Okay. Even touch screens, the screen will wear down, even though the submit button won't. Something to think about. So I'm going to leave this with you to watch for a while. It's really up to you. Ooh, what happened there? I think it depends on when I'm clicking. See if I click on it at the wrong time or too quickly. Okay. That's it. I hope you enjoyed this presentation. It was quick. It was mostly just a demonstration of some of the work that I did and some of the work that I enjoyed doing. I know a lot more about the internet now. Have a good day.